afternoon. Welcome to the University of Tennessee Nuclear Engineering Department Colloquium Program. My name is Lee Dodge, and it's my privilege to introduce today's speaker, who is Mr. Karl. He is the Chief Nuclear Officer and Executive Vice President for the Tennessee Valley Authority. Karl received a BS in Mechanical Engineering from the University of California, Berkeley in 1982, and then he received an MBA from Golden State University in 1989. He was with the U.S. Navy Nuclear Submarine Program from 1982 to 1984, after which he joined TVA. He's been with TVA since 1994, rising through the ranks until he's now the Chief Nuclear Officer for the Tennessee Valley Authority. As a side note, TVA just recently gave our department a nice contribution for our DOE matching grant program, and we sincerely appreciate that contribution. The title of Karl's presentation today is TVA and the Future of Nuclear Power. Ladies and gentlemen, please welcome Mr. Karl.
Thank you, Dr. Dodds. Well, good afternoon. I'm very happy to be here today, but I've got to tell you right up front, I'm very technologically challenged, and there's buttons and special pointers and things like that, so I'm sure it'll be an entertaining 50 minutes or so while I'm speaking to you. We have a number of UT graduates at TVA, as you might imagine, and before I came today, I stopped by a few that I knew, and every one of them told me football stories, and I had to share one with you today. Football story about the Vols and going to the game. This individual as an engineer working inside a nuclear, saw the same couple every week, or every home game out on the field. And one week the wife was missing, and he leaned over. He said, "Hey, where's your wife?" And the person sadly reported their wife had passed away. And he said, "Well, geez, I'm surprised you couldn't get a friend or a family member to be with you today." And he said, "No, they're all at the funeral." Yeah. So anyway, the people who work for me laugh more than that, by the way. Okay, we're gonna get moving here, and we'll try to be informative. I'm going to talk about a lot of different topics in the hopes that maybe one or two will actually be interesting. So we'll go ahead and get started. Normally I would say next slide here, but we'll see how this goes. All right, these are a little bit busy, but I'll go ahead and try and talk through them and cover the salient points. The nuclear industry is kind of going through a dying era and a rebirth era, and I'm going to cover that in some detail today with you. Over the past, we have developed a proven track record of safe, reliable operation. Our capacity factors have improved in the last several years to the point to where it's almost like we built new plants. In fact, over a 3-year period, we essentially added 2 new plants virtually by improved efficiencies and capacity factors. However, the fact of the matter is we haven't built a new nuclear plant in many years. The slowdown started in the mid-'70s. You may or may not be aware of that. How many people in here have heard of 3 Mile Island? Good, some. Not everybody. Some of us were actually alive then. 3 Mile Island certainly didn't help our industry. In 1984 alone, we canceled 16 plants that were in a construction mode. And in total, over 100 construction projects to build nuclear plants were stopped in the 80s, and the last ones in the 90s. As you may know, Tennessee Valley Authority was the last company to do a new plant in the last century, and that was up at Watts Bar. Okay, 2 slides, 2 clicks, I'm on a roll. Forecasts for the future. Right now we're looking at about 393,000 megawatts of power that we're going to need in the country. And that's arguable. You'll see the numbers in front of you. The growth rate will generate about 1,300 to 1,900 plants. That's at about 250 megawatts a plant. A nuclear plant nowadays will run at least 1,000 megawatts. It's just too inefficient to run them at any lower power levels than that. I mentioned the capacity increase throughout the country is added virtual nuclear power plants. TVA contributed to that. We had our best year ever last year for equipment reliability with only 6.2 effective full power days lost for all 5 units. So TVA is contributing to the renaissance there. You might have noticed last night, if you listened to the State of the Union address, that nuclear energy was mentioned again by the President. And the current policies are certainly supportive of new nuclear plants as well. Okay, Let me talk now about TVA, and the agenda here is I'm going to talk broadly about TVA and get more and more specific about TVA nuclear and then some of the projects we're working on and some things you may have read about in the papers about TVA nuclear. But first of all, let me start by saying that TVA is not just an electricity company. It's a different kind of company altogether. And as Dr. Dodds mentioned, I came from the submarine force in the military, where I always had a sense of a broader mission than just getting a paycheck. And one thing TVA's given me is that same sense of a broader mission. I just don't generate electricity. I'm part of something larger than that. And I like this, I'm going to try to use more technology here. I like this quote here, and I use it in almost every one of my presentations because I think it really describes us well. It's from 1933 when the TVA Act was signed, and the picture you see on that slide is Franklin Roosevelt signing the TVA Act. And I'll just read it for those of you who may not be able to. His vision for TVA, and I'll quote, "A corporation clothed with the power of government, but possessed of the flexibility and initiative of a private enterprise." So that's kind of like government on steroids, or government being agile and fast, and that's what we like to think we can do. And we've achieved it in many, many areas. What do? We call it the 3 E's. We do economic development. That's just bringing jobs in the valley, making the valley a place where you want to move your business and move your people to. Energy, that's electricity, providing electricity to folks who need electricity to run their businesses, power their appliances in their homes. And the environment, maximizing the total package is what TVA is about. How do you maximize the use of the river, environmental controls, still deliver safe, reliable electricity such that you get a total product that's not just electricity, but involves things like recreational activities as well. Some more overview. We're the largest wholesaler of electricity. That means we sell power to the people that sell power to you. Now, we do have some direct serve customers. You'll see 61 on the slide. And those are folks, large factories, large businesses that we directly power up and bill them directly. Our service area has about 8.5 million folks in 7 states. And our revenue is about $7.8 billion, roughly $8 billion. The breakdown, we're always asked to break down TVA nuclear. The nuclear portion is about a quarter, 28% to be precise, about 62% coal and 10% hydro. So if you look at where our electricity comes from, that would be your Pareto of how we generate electricity over the course of the year. Okay, we had a big test last summer. In July, we had 8 peak days in a row. And that tested us pretty severely. During those days, we had peak demands all 8 days over 29,000 megawatts. It was the first time ever we had more than 2 days in a row. We had 8. During that time, nuclear and fossil fleet met the demand. We ran at 100% power in nuclear every one of those days flat out. And then on July 26, we set our highest record ever at 31,924 megawatts. Okay, now locally, where do we think demand is going to go, and how does that play into TVA's future plans? Right now, our typical or average forecast is for 1.4% load growth. Now, those of you who might think you wasted your time in statistics class, you probably didn't, because this is a family of curves. It's a statistical probability that we lay out, and that's how we determine what the most likely is. But we also look at the 90% chance and the 10% chance. And we manage our risk based on that. When you go through that analysis, you come up with your best estimate of about 1.4. But to give you a feel for the span, it goes as high as 2.8% and as low as minus 4% in actual load loss. But the most probable is 1.4. So when we lay that forecast out and we go into the future and we use our family of probability curves, we come up with a most likely scenario that says somewhere in the mid-2012, 2018, in that time frame is where we will need more baseload power of any significance. And that's how we manage our planning process. Okay, now getting a little bit more specific to nuclear. We have 5 operating units. We have a 6th unit we're starting up at Browns Ferry Unit 1. That project you may have read about is getting a lot of attention. That's something that TVA is really taking a leadership role on. In May 2002, the board made a a pretty gutsy decision to go ahead and start that unit, knowing that large nuclear projects aren't out there. We have the only large nuclear project. That project's on budget and on schedule, and we're demonstrating to the country that you can do a large nuclear project and be successful, and we feel the pressure of that. Senator Lamar Alexander, and I'll paraphrase, I won't try to quote him, in one of the energy hearings, basically commented that the eyes of the nation were on the performance of Browns Ferry Unit 1. So we feel just a little pressure when we hear things like that. But we're on budget, on schedule. Things are going well there. The team's delivering. Sequoia, 2 units at Sequoia and then 1 unit at Watts Bar. I'll talk about Watts Bar Unit 2 not being completed in a few minutes. You've also probably read a little press about the 2 units at Bellefonte and a relationship we have in a consortium called New Start, which I'll also talk about in a minute or two. So that's TVA Nuclear, 5 operating units at 3 sites, 1 unit coming up to make 6. Browns Ferry Unit 1, I mentioned earlier, $1.8 billion, billion with a B project. It's $1,800 million. I keep reminding everybody how much money that is. We're on schedule and on budget, and it will add a lot of confidence to the rest of the industry that's watching it when we deliver on time and on budget. A lot of things have to go right in a regulated environment for us to be on time and on budget, so that'll be a strong demonstration. License renewal. This is one of our specific projects that I'll talk to you about today, and it will essentially extend the life of our plants. Our plants were licensed for 40 years originally, and this will add 20 years on top of that. It involves extensive engineering analysis of equipment to make sure the equipment, particularly safety-related equipment, can sustain another 20 years or perhaps need to be replaced or require a different maintenance program. So there are many options we could do, but we have to demonstrate with confidence and reliability that these units can operate that much longer safely and reliably. Sequoia and Watts Bar have not been submitted. Browns Ferry was, as part of the Browns Ferry 1 business decision. The decision was made it was not cost effective if we could not also extend the license. So that's why we did Browns Ferry first. Sequoia will be the next one we do, and then Watts Bar after that. Watts Bar being our newest plant, we have a lot of time before we need to extend its license. The requirements I mentioned earlier, it's primarily aging equipment management. How can you demonstrate to ourselves and to the regulator and to the public that we can continue to operate these plants safely, and how do you know your safety systems are going to be just as reliable in the future with another 20 years added on as they are today. We have to also evaluate the potential impact on the environment. Everything we do requires, of this magnitude, requires an environmental impact statement, and of course we went through that process at Browns Ferry Unit 1. Extended power uprate. This gets a little bit more interesting, and we throw some different kinds of numbers at you. You'll see power numbers like 3293 instead of 1200, which you saw on some of the other slides. This is megawatts thermal. We do that just to confuse you, as opposed to megawatts electric. Megawatts electric are the electric power we put to the grid. Megawatts thermal are the reactor power. Now, most of you are engineers and smart people. You've probably already done the math. It's about 37% efficient. I see the smiles of people who did the math. So we generate about 3,293 megawatts of energy in our core, and we deliver to the grid about 1,200 or 1,150 megawatts. So we're going to, what this uprate does is essentially raise our reactor power levels and our deliverable power levels such that we get 150 megawatts of electric more. So that requires a lot of things, and we brought a pictorial here I'll kind of talk through. This is a simplified, very simplified schematic of our power plant, and for those of you who can't read it, I'll talk through it. Of course, we have our reactor in an uprated condition. We got to get a lot more energy out of the reactor, so we have to load more fuel, but we want to run it just as long a period of time, so we have to run it at a higher power density. So we'll have a higher power density core that can provide the energy that we need to get the additional power. The turbines have to require some upgrading, particularly because of increased steam flow and velocities through the turbine. So the turbines require some upgrading. And then this train down here is essentially your water train coming back to your reactor vessel after it's been condensed. And that train requires a lot of new pumps and valves and motors. Higher energy requires higher flow rates, just bigger pumps, motors, and valves. Heaters have to be replaced. This is where we recapture some of the heat to get our thermal efficiency up. So we make changes in there as well. And then a lot of core parameters have to be changed, and we have to demonstrate it's safe to run at the higher power densities. So that's what the upgrade project will do. Okay, one of the other projects you might have read about was our steam generator replacement at Sequoia. Yeah, you have to do this too. Anybody know any good jokes? Thank you. Okay, steam generator project. We did replace them at Sequoia. That's a huge project. You really don't get a feel from this picture how big these steam generators are. But this is a steam generator going into containment. A lot of you may have seen containments from the road or from the river. They're huge. This is a person right here. That's one individual, so you can get some sense of height. What we did is cut two 24 by 45 foot holes in the top of this concrete. Two of those, we did it with 2,000 psi water lasers that essentially cut into the concrete and rebar and circle it out. Now you might wonder, how do you keep it from falling down? You cut it on a bevel such that it can't fall down. It's supported by the rest of the containment. So this project required the world's largest mobile crane. It came in on 145 tractor trailers, which, as you might imagine, was a nightmare for our security force, who had to search every one of those trailers head to toe. 145 of them. It took 18 days just to construct, just to build the crane. Then we had to build an elevator up, platform on the top, start our hydrolasing, and then load 4 of these, get 4 out, and then load 4 back in. Large project, you can see the costs. And there's a big difference there, and it might interest you to know the difference is not just labor or normal escalation, it's the price of materials. Tubing, things like that in the world have gone up dramatically. And so the cost of doing these large projects that require a lot of materials has gone up very dramatically. Okay, I mentioned the nuclear renaissance, which is a term that's kind of out there that describes the condition we have where people are talking about, but no one's committed to actually build a new nuclear plant. We're a part of 2 consortiums. One is an advanced boiling water reactor consortium, and I'll tell you it's kind of dormant right now. That technology hasn't taken off and probably won't take off. It's not being pursued very aggressively by the vendor because the vendor has an advanced technology they prefer for the industry to go to. And although they are already built, which minimizes our risk because they're already built in Japan, we know they can be built and they run. There's not enough interest in the United States to generate more than 1 or 2 utilities that will buy it, and that affects our supply chain. You don't want to be the only one who has one type of reactor because it'll be hard to maintain over the life of the plant. You want to be part of a larger group so that you can have a supply of your parts and materials and fully leverage standardizing procedures and the way the equipment operates. So that's kind of dormant right now, and I think most experts would tell you that we don't expect to see a lot of activity in the advanced boiling water reactor arena right now. The other arena is through a consortium called New Start that we're participating in. The Bellefonte site and TVA were selected for a combined operating license for technology called AP1000, marketed by Westinghouse. It's a pressurized water reactor technology, and several utilities have signed up to developing early site permits and combined operating licenses that would eventually construct that technology. Just for clarity, in the papers don't always get this exactly right. We are committed to do a combined operating license, which would essentially develop the engineering behind how you would build a plant, and it would be approved by the Nuclear Regulatory Commission. But we are not committed to go on with construction yet. That's a decision that will be made in the future. It'll certainly be something that our new board will want to ask questions about when they are finally confirmed. The other activity that we're considering is Watts Bar Unit 2. Watts Bar Unit 1 is up and running. I mentioned that earlier. We have it partially completed, maybe half completed. Watts Bar Unit 2, slightly less than half maybe. And we're considering doing what we did at Browns Ferry there, essentially cookie cutter the next unit at Unit 2. So those are our alternatives in the future, something with New Start and Bellefonte and something with Watts Bar, neither of which have we committed to. Okay, summary of our generation position. Our primary focus right now is successfully completing Browns Ferry Unit 1. I mentioned how important that is to TVA and the rest of the industry that we'd be successful in doing that. Our preferred path of doing any kind of formal construction of any magnitude in the future would be to have a partner. A partner would be a local company, maybe utilities, maybe a combination of folks who would partner with us and share in the risk of developing whatever the next generation would be. And continuing to study the options. We're very aggressive at trying to understand our future. We're very aggressive at producing good modeling techniques that result in good, solid business decisions. One thing I thought I'd share with you that you probably wouldn't get in a class or get out of a newspaper article about us would be something we talk about in every one of our management meetings where we get together and about quarterly and just talk about how can we be better leaders and better managers. And that's what we call safety culture. And it's not something that I see you can use every day as a student, but it's certainly something that if you're going to be in this industry, you're going to have to develop eventually. And I challenge you to look for opportunities where it may apply to what you're doing today. I'll cover a couple of them. We're committed to safety consciousness in everything we do. Everything we do. And what does that mean? What does a safe culture look like? It means people can raise any concern they have without fear of retribution. If you see something that's not right, we expect you to bring it up. Lots of discussion about the issues. Employees demonstrating a questioning attitude. We encourage that. We want people to question us, challenge our assumptions, especially. How do we know it's okay? How do we know it's right? Strong and respected oversight. Having organizations that are strong and can tell us where we need to improve. And last but certainly not least, trust at all levels of the organization that we'll do the right thing. We want people to know that we will do the right thing. And that's the end of my presentation. I'll be glad to answer any questions. Yes, sir.
Why, when I last toured the TVA nuclear facility control rooms, I noticed that the control systems and what I saw on the panels looked quite obsolete. I saw strip chart recorders, analog meters, hand valves, the whole bit. I was reminded of a World War II submarine movie. Now, in the report from the 3 Mile Island accident, it was recommended that the nuclear industry go to something like a
human factor.
A microprocessor, based system that would analyze incoming data, prioritize it, and eliminate this problem that appeared in that accident of everything lighting up at once, so that the operators would have a prioritized procedure for dealing with the situation. Now, is that going to be a fundamental for the new reactors that you'll be ordering?
Well, it's a fundamental for the existing reactors that we're operating today. They all comply with the recommendations of the Kennedy Commission and all the reports that came out of 3 Mile Island. And you're right, you do see strip chart recorders. I will tell you that the flip side of new technology is it doesn't always work. And so when you have equipment that is reliable, that you have a mean time to failure history on based of thousands and thousands of operating hours, it's hard to trump that just because it's new and it looks better. So we make very conscious decisions about what we upgrade and what we don't. Not all of which are just automatically go to digital, but our control rooms are all human factored for exactly the kinds of conditions you talk about, where there are so many alarms you might overwhelm an operator and they can't figure out what's going on. Good question, thank you.
Do we have other questions from the audience?
Yes, sir.
Larry, Dr. Miller?
Everybody's going to be on that side because you're on that side. That's how it works.
There has been some news about Westinghouse being sold. Do you expect that to influence your business plan?
No, I don't. I think that's public knowledge that they have been sold. I believe Toshiba is the buyer, and I think the number was $5 billion. I don't think it's going to influence the decision in the short term. How the future plays out remains to be seen. We've gotten a lot of assurances. I got phone calls right away about no change in direction and a leadership team that's going to remain firmly in place. So I don't see anything right now that would undermine our confidence in our ability to deliver.
Okay, we do have a question from the cyber audience. This comes from Brian Hajek, who some of you know is a nuclear engineering professor at Ohio State University. He's listening to your presentation.
So there is a cyber audience.
There is a cyber
I thought
audience.
maybe it was all turned off.
And his question is, why did Watts Bar need a new steam generator so soon?
That's a great question. Two reasons. One is they run at a higher T-hot. They run 30 to 40 degrees higher than the temperature of a typical PWR, which accelerates the type of corrosion that we're concerned about, which is very temperature dependent. It's called intergranular stress corrosion cracking. So it's a temperature driven phenomena. And second, it's made of an alloy that is known to be very susceptible to that type of cracking. So we measure at each outage our tube cracking. When we find cracking, we go ahead and plug it in. We have a strong industry curve that helps us predict about at which we start to lose efficiency, and that's how the decision was made to go ahead and change those out based on that. The two primary reasons are the higher temperature and that particular alloy susceptible to that cracking. Yes, sir.
I'd like to make a comment on that.
Give him the mic. Use the
Watts bar
microphone.
generators, the Watts bar generators were originally installed back in the 70s. And the plant was originally scheduled to start up much, much earlier than it did. So those generators are not as young as one might think for a plant that started in the mid-90s. It really started back in the 70s and 80s.
Well, I agree, but again, by monitoring at each cycle, we go in and we inspect every tube or all the inner tubes, and if we find anything, we expand the sample size. But by doing that inspection, we're very confident in the rate at which we're starting to see the first signs of cracking. And it is following the industry trend. It's a very predictable response, well understood. And because they were sat there in a layup condition where we preserved them, not running at a T-hot, which is that highest temperature in the plant. It's T-hot is the temperature of the reactor exiting, or the water exiting the reactor. It's sitting there at ambient temperature at the temperature of the building. So that corrosion phenomena wasn't ongoing during the period it was in layup. Does that answer your question?
Yeah.
Thank you. Yes, sir.
Yeah. What do you see for your future workforce needs, and what are you doing to prepare for that?
Well, that's an excellent question because we're challenged like the rest of the industry is. We have an aging workforce. Our demographics has a large hole in the 30 to 40, 45 region that's not going to get filled till we get a pipeline going beneath it. And you saw a lot of growth in the industry potentially. So we're challenged. Now, at TVA, we started doing things probably ahead of everybody else. We have apprentice programs going before anybody else in the industry. We started up new apprentice programs. We have large classes of our assistant unit operators, which is our entry-level operation positions. We have apprentice programs going in maintenance now and have for the last couple of years. So we've really started doing the kind of entry-level stuff. On top of that, we're focused on retention. We've started new programs that we've gotten from benchmarking people outside the industry, like British Petroleum. I was at BP in Decatur, Alabama, and happened to see a process where any employee can submit their name and go in front of senior management and ask a question like, what would it take for me to be a plant manager? And so we kind of stole that idea with their permission, obviously, and we're implementing that now, so it gives people a better sense that they have a good career at TVA. So it's twofold. You got to get entry-level folks coming in to meet your future needs, and you got to keep the fine people you got today because it's going to be a highly competitive market for nuclear folks out there, especially if we start constructing new plants. Yes, sir.
With respect to plant license extension, when does the clock start running on a 20-year license for Watts Bar?
That's a great question.
'Cause the plant is a lot older
35.
than that.
Yeah, it's 96 plus 40, so it's like 35,
Yeah.
2035. So we would submit, obviously, a little bit before that and run it 20 years from there.
But a lot of that plant is a lot older
It is. It is. And it's similar to the steam generator question earlier. The steam generators were sitting there that long. His question was, for those of you who didn't hear because Mike wasn't there, his question is, well, the plant's older than that. Some of those pumps and valves, my words, not yours, have been there all along. We have to address that in the aging management program. We are expected to answer every one of those questions, not broadly, but by pump and by valve. What about this pump? What about that valve? And that's the expectation we'll meet. To answer your question, sir?
Okay. Do we have any other questions from the audience? Okay. Well, I think that we probably should consider adjourning downstairs where there's refreshments, food and whatnot. We do have a few new faces in the audience, and it seems like we always do every week. And the new people may not know that we do have a reception downstairs and everyone is invited. But before we adjourn downstairs, let's express our appreciation again to Mr. Singer for his presentation.